Hi everyone. In this video, we are going to discuss what is exact differential equation. Actually, I am preparing a complete playlist on which this topic exact and non-exact differential equation. In this playlist, I am going to solve several examples of exact and non-exact differential equation. I will teach you how to solve, what are the different methods of solving exact and non-exact differential equation. The most important thing is at the end of each video, I'm going to give you some exercise problem for you. You're supposed to watch the video and you're supposed to try the exercise problem on your own. And if you face any difficulty, definitely my next video will be there for you, in which I will discuss that exercise problem in details. Okay, so let us start. In this video, in this first video, we are going to discuss what is exact differential equation and how to identify it, right? So basically the definition is an exact differential equation is a differential equation which is obtained from its primitive by differentiation only. Okay, it is looking quite difficult. So let us try to understand its meaning with the help of example, right? Suppose I take one function u is equal to x square plus y square. Okay, we are trying to understand the meaning of exact differential equation, right? So u is equal to x square plus y square, any function I have taken of two variables x and y. So this is its primitive. This is its primitive. Okay. So with the help of this u, I am going to find a differential equation. Then du is equal to, what can we write? It's a function of x and y. So del by u by del by x dx plus del by u by del by y dy. So let us put the value of u. Del by y del by x, value of u is x square plus y square dx plus del by del by y. U is x square plus y square dy. Simply I am putting the value of u here and there. Let us find partial derivative. Partial derivative with respect to x, it means when you take derivative, we consider y is a constant. And del by del by y, that means when you take its derivative with respect to y, we consider x as a constant. Addition is there, I will take separate derivatives. Derivative of x square is 2x, right? I am using this formula of derivative here. Let me mention. The formula of x raised to n, derivative of x raised to n is n x raised to n minus 1. This formula I am using to find its derivative. Derivative of x square is 2x plus y square. But see, we are differentiating with respect to x, so y square is a constant. Derivative of constant is 0 dx plus, now derivative of this one with respect to y. Addition is there, I will take separate derivative. Derivative of x square is 0. Since we are differentiating with respect to y, x square is constant. Derivative of y square is 2y, dy will be there. So this is 2x plus 0, 2x dx plus 0 plus 2y, 2y dy. So I got this. Now I compare this du with 0. Then du is equal to 0. It means if you put the value of this du, you will get 2x dx plus 2y dy is equal to 0. Getting? So we got a differential equation here. Getting? We got a differential equation. Differential equation means what? An equation, that means equal to sign, in which derivatives are involved. So this is a differential equation, getting, which is obtained from its primitive. So that's why we say it is exact differential equation. Understood? This is exact differential equation. But see, this is the actual definition of exact differential equation. But when we solve the problems, we never go for that. We have a necessary and sufficient condition. With the help of that, easily we can decide the given differential equation is exact or not. Okay, just note down this part and then we will move for this necessary and sufficient condition. So let us discuss necessary and sufficient condition now. Okay, so a differential equation which is in this form, m dx plus n dy is equal to 0. Okay, this differential equation is exact if delta m by delta y is equal to delta n by delta x. Getting? So you can easily see m, that means it is a function of x and y. N is also a function of x and y. For example, let me write one example here. See, x square plus y square dx plus 2xy dy is equal to 0. Okay, so very simple example I have taken. Some function of x and y into dx plus some function of x and y into dy. So this is my m, which is a multiple of dx, and this is my n. You can see this is my m and this is my n. Getting? So when we say it is exact, if this condition is satisfied, derivative of m with respect to y, actually m is a multiple of dx, but see, we take its derivative with respect to y, we take the derivative of n with respect to x, and if both of them are same, then we say the given differential equation is exact. Clear to you? Okay, so let us discuss few examples so the concept will be clear to you. Okay, so just me remove this part. Okay, so let us discuss one example. First example, let me note down here, tan y plus x dx plus x sec square y minus 3y dy is equal to 0. So this is one differential equation we have, and we are going to check whether it is exact or not. So first of all, we will check the given differential equation, is it in standard form or not. What is the standard form? Let me clearly mention this standard form. M dx plus n dy. Multiple of dx, this is our m, and multiple of dy, this is our n. That means the given differential equation, is it in standard form. So let me clearly mention m. What is my m? Tan y plus x. N is x sec square y minus 3y. Okay, so now we are going to check whether it is exact or not. It means simply it should satisfy this condition. Derivative of m with respect to y must be same as derivative of n with respect to x. So here frequently we find derivatives, and when we solve differential equation, frequently we solve integration also. So that's why formulas of derivative of and integration should be perfect. Okay, you should prepare the formulas first. When we solve the examples, I will mention the formulas each time, but when you appear for the examination, the formula should be perfect. Then only you can easily solve the problems on your own, right? So let us find derivative of m with respect to y now. Now, derivative of m with respect to y. Okay, I'm going to put the value of m. What is value of m? Tan y plus x. You can see addition is there. We can take separate derivatives. Derivative of what? Tan y plus derivative of x. See, derivative with respect to y we are finding, right? So derivative of tan y, you know derivative of tan y is sec square y. So I should mention here sec square y. We are finding derivative of x, but we are finding derivative with respect to y. When we find derivative with respect to y, x is a constant, and derivative of constant is always 0. So 0 plus sec square y, sec square y. So the half task is completed. We found out the derivative of m with respect to y. Now we should work on derivative of n with respect to x. Let us do. Derivative of n with respect to x. What is my n? My n is this x sec square y minus 3y. I will put it there. X sec square y minus 3y. As you know, when you have addition or when you have subtraction, we take separate derivatives. I will take separate derivatives. Derivative of this x sec square y minus derivative of this 3y. Okay, derivative with respect to x. I'm making mistake. Derivative with respect to x. I'm taking separate derivative, right? So there are two functions. First is x and the second is sec square y. See, we are differentiating with respect to x. That means this x is a variable and sec square y is a constant, since we are differentiating with respect to x. So when you have any constant in case of differentiation, we take it outside. So I will take this sec square y outside, sec square y outside. So inside the bracket you have simply x. Let us talk about this. We are differentiating with respect to x. That means y is constant. 3 is also constant. So that means the entire term is constant. Tell me what is derivative of constant? Derivative of constant is 0. So it is 0 minus 0. So sec square y, derivative of x with respect to x is 1. So 1 into sec square y, sec square y. So dabba m by dabba y, sec square y, dabba n by dabba x, that is also sec square y. That means both of them are same. Right? So both of them are same. So that's why you can declare, therefore, given differential equation is exact. Finish. So in this way, we got the given differential equation is exact. Let us discuss few more examples. Just make a screenshot of it, then we will go further. So let us discuss this second example. Okay. So in this second example, see, let us check first the given differential equation. Is it in standard format or not? Standard form is m dx plus n dy. Multiple of dx is this bracket. It means it is our m. Multiple of dy is a second bracket. That means this is our n. Let me clearly mention here. What is my m? X square minus 4xy minus 2y square. What is my n? Y square minus 4xy minus 2x square. Okay, so when we say it is exact differential equation, if it satisfies this condition, derivative of m with respect to y is same as derivative of n with respect to x. Let us check. I'm going to find derivative of m with respect to y. Okay, with respect to y. Let us put the value of m, x square minus 4xy minus 2y square. So there are three different terms, getting, which are separated by minus sign. So I can take separate derivatives. Derivative of this x square minus derivative of this 4xy minus derivative of this 2y square. After that, generally what I do, if there are any constants inside the derivative, I take them outside. Let us find. We are finding derivative of x square with respect to y. But when we are finding derivative with respect to y, that means this is a constant. Getting, there is no any y, it's a function of x, so it's a constant. What is derivative of constant? 0. Directly I can write 0 here. Let us move further. So now we are finding its derivative with respect to y. Y is there. It's a variable. Y is a variable. 4 is constant, as you know. X is also constant because we are finding derivative with respect to y. So 4 and x, both of them are constant. They will come outside. 4x, simply derivative of y. Y square is a variable. It's a function. Getting y square. Since we are finding derivative with respect to y, it's not a constant. 2 is a constant. It will come outside. Y square, right? So minus 4x, derivative of y is 1. Minus 2, derivative of y square. Let me tell you the formula. Okay. So with the help of this formula, you can find any derivative of any higher power of x or y. So what is derivative of x raised to n? N x raised to n minus 1. This is a formula we have. Whatever the power, we write it there and we reduce the power by 1. So what's the power here? 2. So here also, let me, I should write this 2 here, 2 before y, and we reduce the power by 1. So 2 minus 1, 1. So that's why we get derivative 2y. So minus 4x into 1 minus 4x minus 2 into 2, 4y. So this is required value of dabba m by dabba y. Now I should find the value of dabba n by dabba x and we will check both of them are same or not. Let us do. Let me remove this part. Okay. Let us continue here. Dabba n by dabba x. So let me put the value of n. What is value of n? This is value of n. Y square minus 4xy minus 2x square. Tell me how many terms are there? 3 terms are there. First, second, third. And all of them are separated by minus sign. So I can take separate derivatives. Derivative of y square minus derivative of 4xy minus derivative of 2x square. Okay, after that what I do generally, I take the constants outside. We are differentiating with respect to x is not there. There is only y square. So it will be constant, and derivative of constant 0. X is there? Yes, x is there. Other than x we have 4 which is constant, and y also constant here since we are differentiating with respect to x. So 4 and y, both of them are constant. You can take them outside. So derivative of x is there only. 2 is constant, you can take it outside. So x square. So minus 4y, derivative of x is 1 with respect to x, minus 2. Derivative of x square, same formula I will use. What was derivative of y square? 2y. Similarly, derivative of x square is 2x here. So it will be minus 4y into 1 minus 4y, minus 2 into 2, 4x. So here minus 4x minus 4y, minus 4y minus 4x, both of them are same. So you can say this is exact differential equation. Therefore, delta m by delta y is equal to delta n by delta x. Therefore, given differential equation is exact. Okay. Let us discuss one more example. Just make a screenshot of it, then we will move further. So let us discuss this next example. Okay. So let us check first, given differential equation, is it in a standard form or not? So m into dx, some bracket into dx, that means this is our m, plus second bracket into dy, which is nothing but our n. So let me note down our m and n. So here m is 3x square y raised to 4 plus 2xy, and n is 2x cube y cube minus x square. Okay, simply we have to check this condition is satisfying or not. Let us start. Delta m by delta y, right? So let me put m here. What is my m? 3x square y raised to 4 plus 2xy. You can see there are two terms which are separated by plus sign. I can take separate derivatives. So 3x square y raised to 4 plus derivative of 2xy, right? Okay. Sorry, this is derivative with respect to y. This is derivative with respect to y, right? See, when we take derivative with respect to y, we consider x and functions of x are constants. Let us find constants outside. Okay, let us take constants outside. 3 is a constant, you can take it outside. X square is also a constant. Since we are differentiating with respect to y, x is constant. So 3x square we have taken outside. Inside the bracket we have y raised to 4. What will be the constant? Tell me. 2 is a constant. X is also constant. Since we are differentiating with respect to y, 2x constant outside y. So 3x square. So let us see how to find derivative of y raised to 4. I am going to use our favorite formula, that is nx raised to n minus 1. Whatever the power, okay, we write here before that function and we reduce the power by 1. So power is 4. If you reduce it by 1, it will be 3 for y cube plus 2x, derivative of y 1 obviously. 3 into 4, 12, x square y cube plus 2x into 1, 2x. So I got the derivative. Let us move further. Let us find delta n by delta x. Okay, let us find delta n by delta x. Okay, delta n by delta x. Let me check what is our n. Our n is this one. I should put it here. 2x cube y cube minus x square. There are only two terms which are separated by minus sign. I can take separate derivatives. 2x cube y cube minus x square. See, we are differentiating with respect to x. That means y is constant. 2 constant, you can take it outside. Y cube is also constant. You can take it outside. So 2y cube derivative of x cube, right? Derivative of x square, same formula. Can you tell me? 2 power I will write here and I will reduce the power by 1. So 2 minus 1, 1. If the power is 1, no need to write. You can keep as it is. So 2y cube, derivative of x cube, same formula I will use. 3 I will write here and I will reduce the power by 1, it means 2 minus 2x. So let us multiply 2 into 3, 6, x square y cube minus 2x, right? Let us check both of them are same or not. Same? No. Both of them are different. So I should mention here delta m by delta y is not equal to delta n by delta x. It means given differential equation is not exact. Getting? So in this way we decide the given differential equation is exact or not. If it is an exact differential equation, we have a method to solve. In next video we are going to discuss, but don't worry, if it is non-exact, then also we have few methods. With the help of them we can definitely solve such problems, right? Make a screenshot of it, then I'm going to give you 2 problems for exercise. So these 2 problems are homework for you. You can try these problems on your own. Getting? You have to check simply the given differential equations are exact or not. Either the first, both of them are exact, maybe both of them are non-exact, or the first one is exact, second one is not exact, or the first one is non-exact, second one will be exact. Whatever you will get answer, you can write in a comment. I will check and in comment I will reply to you the actual answer. Okay, so we will stop here. In next video we are going to meet with few methods of solving exact differential equations. Okay, see you, bye.